Hey, welcome. All right, so today we're going to look at some review topics, looking at order of operations and some exponent rules. Now, one of the things that actually pops up quite often, and it usually deals with our graphing calculator, is sort of the difference between a -3 that is in parentheses to the fourth power versus just a -3 to the fourth. Is there any difference between them? And there is a difference, and your calculator will calculate those differently, and it really has to do with the order of operations. In this first scenario, we're doing inside the parentheses first, so we are acknowledging this is a -3, and we are taking the full value, the -3, to the fourth power. So that's going to be a -3 times a -3 4 times. All right, so 3 times 3 is 9, times another 3 is 27, times another 3 is 81. And since you have 4 negatives there, it's going to be a positive 81. But over here on the right is a more common way that we probably just type it in the calculator. It's a -3 to the fourth, and we just do it quickly. But the problem with typing that prop into your calculator like this is that it, again, is doing the order of operations, but without the parentheses, it's doing this exponent first. It is taking the 3 to the fourth power, and it's getting it to be an 81. And this negative out in front is like a times -1. So it's ultimately doing this to you. It's a -1, and then it's the 3 to the fourth, which is the 81, and we get a -81 for an answer. All right, so these are interpreted differently. Make sure that if you're trying to take a full value, a -3, to the fourth power in your calculator, you have to include these parentheses to make it come out to be that positive. Or just use some common sense. If you were to type this in your calculator in your mind thinking you were doing this, you should have, be alerted that, oh, why is that negative? That should be positive. And so have that awareness on your calculator. All right, so let's look at these next two and the difference between these. Well, in this scenario, the 5 is being squared. But in this scenario, the whole quantity inside the parentheses is being squared. So this is going to be a 2 times a 25, the parentheses first, and then you're going to get a 100. So paying attention to where that exponent is. Now, I know you've been doing order of operations for a long time. The main thing I see that people run into errors with is they do a little bit, maybe too much in their head, and they do things that seem like they would work nicely. So don't be afraid to take a couple steps. So when I look at this, and of course we're doing PEMDAS here, so any kind of grouping symbols or parentheses, then your exponents, then multiplication and division, those are done at the same level. Those multiplication, division, you just do them left to right. And then same thing with addition and subtraction. You do those left to right. So looking at this, the first thing that I see is the exponent. So I'm going to go ahead and take a couple steps to make sure I don't accidentally goof something up. So 2 to the 5th is 32. Then I'm going to do the multiplication and division, and I'm going to go through and do them both left to right. So 3 times 9 is 27. Leave the minus sign, but then I'm going to go ahead and do the division. 32 divided by 4 is 8. So there I did the multiplication division. Last step is the subtraction, and I get a 19 for that. Okay, in your notes, anytime you see this little guy here, it means you're supposed to try that one on your own. So you could pause the video and take a minute and try to see if you can do it on your own without me walking through it. And then when you're done, then turn the video back on. All right, so go ahead and pause. All right, so I ended up with a 12. If you also got a 12, then let's keep moving. If not, you might backtrack and look through how I did that problem. Now this one's a little messier. It's got a lot of parentheses with double negatives going on. You got a fraction. Let's just take it nice and slow. First thing I see is this exponent, this 7 squared. Now this goes back to what I had said earlier. The way that this is evaluated without the parentheses means you're going to square it first and then you make it negative. And then I have this minus minus that I might go ahead and change to a plus plus. So that's going to end up being a 49, but I'm going to make it negative 49. And then it's going to turn into a plus 9. Now let's work through the denominator. Now right here is ultimately implied multiplication, as is this right here. So I'm going to end up with a 6 times negative 8, or I'm sorry, 6 times negative 3, which is a negative 18. And then I'm going to go ahead and do a minus, and then 1 times negative 2 is a negative 2. Now you might have done that as a negative 1 times a negative 2. Either way, we're going to land at a positive. So simplifying my numerator gets me a negative 40. Simplifying my denominator gets me negative 16. All right, that does reduce. 8 goes into both of those. The negatives would divide out. So I'm left with 5 halves for my final answer on that. Okay, looks like my little guy is kind of weird here on this. Didn't copy over very nicely, but this is one of the ones where you should be trying this by yourself. What's different here is that we are evaluating, meaning we're going to take these values and plug them into the equation where they belong. And then after that, do your order of operations. Okay, so this one might take a little longer. Go ahead and pause the video so you can work through that. Come back when you're done. All right, my answer is a negative 21. So again, if you agree, let's keep moving. If not, check and see where you might have gone wrong. Now this is a similar problem, but a little fancier because I have absolute values tucked in there all over the place. So let's see how that will play out. So you're going to have a 2, and I'm going to do some substitution. I'm going to take that 13 and put it in right there. I don't think that the absolute value is going to do anything with that because there's nothing that's negative. Then I have a minus 3 and an absolute value of negative 9. And then an absolute value of 13 plus negative 9. So in the numerator, I have a 26, but the absolute value is not going to do anything. And then I have this minus 3, and then in the absolute value is this negative 9. That's going to go to a positive 9. In your denominator, don't think that the absolute value makes everything positive. Like this negative 9 right here is truly a negative 9. What you're doing the absolute value on is the 13 plus negative 9, and that's going to get you a 4. It's already positive. So again, the absolute value aren't really doing anything in that problem. Okay, so then what I have is a 26 minus a 27 over 4, which gets me a negative 1 over 4 for an answer. All right, so we're going to move on to some of these exponent rules. And I don't get too caught up in just memorizing a bunch of rules. Sometimes I just kind of look at it like some common sense. But there are several different scenarios. So you'll have several slides here with this border that indicates you want to remember this. This might be something you can find quickly in your notes. So first of all, anything to the power of 0 is always equal to 1. So it doesn't matter if it's a 924 to the 0 or a 14x to the 0. Anything to the 0 power is 1. But look at this second one. The x is being raised to the 0, but the 14 is not because there's no parentheses. So the 14 is still there. The x to the 0 is what turns into a 1. So this final answer is actually a 14. Another quirky thing is if you have a fractional exponent. So in this example here, I've got a 64 to the 1/6 power. So this denominator here is always going to act as the root of the problem. So that's a 6th root is what that is. The numerator, which in this case is just a 1, acts as your power. So in the end, a 64 to the 1/6 is really the equivalent of a 6th root of 64, which happens to be 2. This next one, a little fancier, the denominator is a root. So this is a square root of 25, which is going to work out fine. That's going to just equal 5. But you still have the numerator, and that's a 3. So you're going to take this whole thing then to the third power. All right, square rooting 25 is a 5, and then to the third. So whatever, oh, I think that's a 125 would be the answer on that. All right, so let's look at some other scenarios. And again, these all have like a rule that you follow, but I also just kind of want it to make sense in your head. I didn't leave us a whole bunch of room to write, so I'm going to be writing teeny tiny here. But when I see a situation where I am multiplying two values that are exponentials here, and I'm multiplying here, they have to have the same base. And when I see that written, here's what I think of in my head. I think I see this written. It's a 4 times 4 times 4, and then another 4 times 4 times 4, and I got 6 more of them here. And so when I look at that, in my head, I'm thinking, okay, so I got 3 here, I got 6 more here. I have a total of 9 of these. So this is a 4 to the 9th power. So what you're doing is if you are multiplying here, then you are going to be adding those exponents together. That's the rule. So let's try the second one here. I've got a 5x to the third times a 12x to the 8th. So ultimately, you can start with your coefficients and you just multiply those. So 5 times 12 is just 60. But then you're also multiplying these two x values. You have an x to the third and an x to the 8th. That gets you an x to the 11th power. Okay, let's try it with dividing. All right, so again, when I see the division in my head, here's what I see. This 6 to the 7th is like 7 6s sitting there. And then on the bottom, I have 4 of them. So what I would immediately do is I'd start reducing. Those 6s are going, those 6 are going, those 6 are going, those 6 are going. And so the way I look at it is when I see this, I say, all right, where are there more 6s? So obviously there's more of them on top because it's a 7th power. And then I say, how many more? And there'd be 3 more. So ultimately what you're doing is you're subtracting those exponents. But you can also think of it, well, I've got 3 extras on top. So that answer is going to be a 6 to the third power. All right, so let's do this other example. The coefficient works differently. Just think of it as a fraction. 12 divided by 6. That's a 2. And then I look at my x's. I have more x's on the bottom. So if I were to start slashing them like I did earlier, I would end up with extras on the bottom. And how many extras would be on the bottom? 6. All right, so now on this next one, we're going to raise a power to another power. And so how I would see that written then in my head, on this first one, I would think that's a 5 cubed times another 5 cubed times another 5 cubed times another 5 cubed. All right, so that's a 5 cubed to the fourth. And then I'm back up here to looking at what I did on these here. Well, if I'm multiplying, which is what I'm doing here, then I'm just going to add exponents. So I end up with 12. Now, I don't really want to have to write this out every time. So if you look here, you can see that 3 times the 4, that's where that 12 comes from. So when you raise a power to another power, you're going to want to multiply exponents. Let's try this example here. It's a little trickier because it has a fraction, but that 3 is going to go on everything that's in the parentheses. So that means it's a 3 cubed, it's an x to the 5th cubed, and it is a 2 cubed. All of those are going to get cubed. So I'm going to go ahead and write a step since these are your notes. It's a 3 cubed, it's an x to the 5th cubed, all over a 2 cubed. All right, so that ends up being a 27 x to the 15th, because we're going to multiply those exponents, over 2 cubed is 8. And that's your final answer on that one. Okay, and then the last little rule that we have is anytime we have negative exponents. Okay, so to get rid of negative exponents, you're going to shift them. When you see a 4 to the negative 2, that really means that the 4 is in the wrong place and it needs to be shifted down to the denominator and be squared. When you shift it, the exponent goes positive. If you have a negative exponent that's already in your denominator, then you shift it up to the numerator. So get rid of negative exponents by shifting up or down. So let's look at this example that I have. The 3 and the 15, those are coefficients. They just work like a fraction. 3/15. That reduces to a 1/5. And now let's look at how we deal with our exponents. This a to the negative third, that means that this a to the third is in the wrong place, and those need to go to the denominator. But when you look down there, there's already an a down there, and I'm bringing 3 more down. So how many a's am I going to have down in the denominator then? It'd be 4. Let's try the b's. I have 4 b's on the top, but then I have this b to the negative 1. That indicates that the b to the first is in the wrong place, and this b to the first needs to go on the top. But if I already have 4 there, and I'm going to bring 1 more b up there, how many b's are on top? 5. And that's your final answer on that. All right, I just put this slide in there in case you wanted a maybe even more condensed version, just a quick screenshot out of the textbook of those different rules. Now, at this point in class, we just partnered up and kind of powered through all of these examples. And I'm just in the video, just going to go ahead and go through each of these examples. All right, so on this first one, what we're going to do is we're just multiplying these together. So using those rules that we just got done talking about, when you multiply, ultimately you're just going to add all your exponents up. So I have 3 r's, I have 4 more, so that's 7, and then I have 1 more. So that's 8 r's. Now, as far as the number part, you're just going to multiply your coefficients together. You have a negative 5 times 6, that's negative 30, times negative 3, that's a 90. So our answer on this is a 90 r to the 8th power. On the second one, we have the power to the power rule. So this is going to end up 2 to the 5. Remember, power to a power, you're going to multiply those exponents, and then that's going to become a y to the 12th. Now you could multiply out your 2 to the 9th. I don't have my calculator handy. I don't know for sure what 2 to the 9th is. It's probably not huge, to be honest. Probably be good to go ahead and write that out as a number. Now that we've taken the notes on there, and you might have an extra slide in your notes of some of those rules all condensed into more of a textbook format, which is fine. But now we're just going to practice some of these and use those rules. So we have this 4 to the 15th is what that would end up being, because a power to a power, you're going to multiply. And then power to the power in the bottom is going to be a z to the 10th. So multiplying exponents. 4 to the 15th is probably a big enough number. I'm just going to leave it as a 4 to the 15th. I don't really want to write that out. Okay, on this next example, I'm taking this fraction to the 2nd power. So it's like the one we did earlier there, where everything in the parentheses is going to be squared. So that includes this number. I have a negative 3 that's going to be squared. Now think about this with the whole negative thing. It's really going to look like this. It's going to be a negative 3 that is being squared. So that's going to make that go to a positive 9. Then you have this a to the 3rd to the 2nd. That's where you multiply exponents. Now everything in your denominator needs to be squared. So the b that's currently to the 1st is going to end up squared, and the c that's to the 4th is going to end up to the 8th power. Okay, let's practice with that whole negative thing one more time, and we're going to put that 0 exponent in and see if you can figure out where that plays a part. All right, this first one, part A, is the very basic 8 to the 0. Anything to the 0 power is equal to 1. But on this one, remember that you're going to do the exponent first, order of operations, you're going to do the exponent, but then you're going to take it times a -1, which is what that negative really is. It's a coefficient out there. So this one's actually going to end up equaling -1 because the power happens before the sign. Unless, like on C, the whole thing is in parentheses. Now the whole thing is to the 0 power. So now you're to a +1. D, all right, this right here is being taken to the 0, so it's going to be a 1, but then the negative out in front of that comes down, and so you're going to end up with a -1. All right, and the last one, I could mess with putting everything to the 0 power, but why bother? Isn't everything in the parentheses going to end up getting you a 1? Just a 1. All right, so these type here, I think, are kind of like the fun ones where you just sit there and you go from letter to letter to letter and you just do your thing. So here we go on number 1. I have an m to the 0. That's really just a 1. That's not even there. It's just like a coefficient of a 1. But here I have an m to the -2nd. So these are in the wrong place. So this m squared has to go up. And I can add it to the m that's there, except that that's really not there. So really it just takes it, so that's an m squared on top. All right, the n that's down here, I just do these alphabetically usually. So n to the -4th, that's in the wrong place, so that has to go to the top. There's none up there to merge it with, so I'm just going to have an n to the 4th on top. And then let's look at the p's. These p's are in the wrong spot. They have to go down. So I have a p to the 3rd that's going down. I already have a p to the 3rd, which is going to end up with a p to the 6th on the bottom. Okay, let's try one more together, and then I'll have you do 3 by yourself. So in this one, I have these coefficients. I have a 2/4 here. So a 2/4 is going to reduce to a 1/2. And then on your m's, all right, so in this case, I have an m on top, and it's just a normal m, assumed to be to the 1st power. This is an m to the 4th. Okay, there's no negative exponents, so there's no shifting. But what you need to remember is if I were to write this all out, I would have one m on top, I'd have 4 of them on the bottom, and I would slash one of them, and I'd be left with 3 on the bottom. So I have an m to the 3rd. I don't know what's going on. My pen just broke or something. M to the 3rd. Oh, it was on highlighter. Okay, now let's look at the n's. Okay, everything is positive, so everything's in the right spot. This n to the 0 is really just equal to 1. Not n to the 1, but just a 1. And since I already have a 1, I don't need to write it again. I think it's just that. And then the n to the 4th is going to stay on the bottom. And then the p has nothing to simplify with, so it's going to be a p to the 3rd that stays up on top. This 1, since we eventually got this p cubed, that 1 would be optional. Either way, whatever you prefer. Okay, now I want you to pause the video and do number 3 on your own. All right, here's what I got. Check it with yours. Make sure you agree. Ultimately, I just took these A's and brought them down here, so that's how I ended up with 8 of them down there. These B's had to go up, so that's how I got to the 5, and then this just went away. Let's talk about fractional exponents. Back earlier with our rules, fractional exponents, we talked about how the denominator acts as the root and the numerator acts as the power. Now, this is going to work great because you can see this 144 that I have, and the denominator is a 2 because 144 is going to square root nicely. But we're really kind of talking about order of operations with this. So when I look at this first example, I'm going to square root the 144, and then I'm going to take it to the 1st power. But taking it to the 1st power isn't really going to do anything, so I'm just going to have this 12. Order of operations says I have to do this exponent before that negation out there. So my answer would be a -12. All right, This next problem is actually the exact same thing without the parentheses. It's still, even without the parentheses, I've got to square root it first and then make it negative. The third example is the scenario where you don't do the negation at the end. It's incorporated inside the radical, so this really is a square root of negative 144. Now, the problem with this particular one, though, is that if I do that, I end up trying to square root a negative, which is going to force that to go imaginary. Now, we haven't talked about imaginary numbers, but those of you that remember from Algebra 2, that would just be called 12i. But I think on your homework, they just say it's a non-real answer because it ends up imaginary. All right. Now, this next one, though, is not a 1/2, it's a 1/3. So now instead of square rooting, you are cube rooting. So we are cube rooting a negative 125. Hopefully you remember that it's actually okay to cube root a negative. You can do an odd root on a negative. You just can't do an even root. And so what you end up doing here is you're looking for the number that you can multiply by itself 3 times and get a negative 125. And that would end up being a negative 5. All right, next one's a little trickier. I'm going to fourth root the 81, and then I'm going to cube it. Now, I'm hoping that the fourth root of 81 comes out nice, and it does. I'm going to do that first just to get my numbers smaller, and then I'm going to cube it after that. So the fourth root of 81 happens to be a 3. And so I have a 3 to the third power. So that's 27. Okay, next one. I'm going to be square rooting, but it's a negative. That's problematic, except that, remember, this one is sort of like this one, that you do the negation at the very end. Sorry, obviously I'm doing this during my lunch hour here. Okay, so I am going to square root so it looks like this. The negation happens at the end. I'm going to square root 4, and then I'm going to take it to the 5th power. The square root of 4 is a 2. And 2 to the 5th is 32. So my answer is negative 32 on that one. All right, let's take a look at some a little bit more challenging ones and tying all these different rules in together. So if you look at this one, remember that the 3 is the root. So I'm going to have to cube root a 216. The 2, I'm going to square that answer. And then the negative means it's in the wrong spot. So it's going to have to bump. Right now it's not a fraction, but I would assume it's over 1. So it would have to bump to the denominator. So I'm going to end up with a 1 over the cube root of 216. Any ideas what you can cube root to get a 216? Okay. Just try around with your calculator a little bit until you figure out that, oh, the cube root. And so here I'm going to write it like this. It's going to be the cube root of 216. I put it in the denominator because it's negative, but it's still going to have to be squared right there. And so the cube root of 216 actually is 6, but that 6 is going to end up getting squared. So I end up with a 1 over 36. Okay, let's try this next one. When I'm multiplying, remember that you add exponents together. Now, it's worth noting here that these exponents are really only on the z's. The coefficient here, these are just getting multiplied. It's almost like you have 4 things that you're multiplying because you're multiplying here and here and here. So you're multiplying all 4 of those things together. How about if we just go ahead and multiply the 4 times the 5? That's going to get us a 20. And then to multiply the z's, I'm going to have to get a common denominator. Because to add those exponents, which is what the rule is, you got to have a common denominator for fractions. So I'm going to take this times 4 and this side times 5. So now what I end up with is a z to the 15/20ths times a z to the 8/20ths. By doing that, I'm now able to add these together. I get a 20z to the 23/20ths, and I'm just going to leave it like that for now. All right, as you look at these next ones, they probably look kind of similar to that idea, but they actually have, are probably a little bit easier. One thing to note here is that these are not common bases. There's no variable here. This is actually the 100 to that power and the 16 to that power, not a variable. Well, these are not common bases, so it's not the same thing that we did up here because they had the common base of a z. So what I'm going to work with here is let's just do the number stuff. So this is the square root. 100 actually square roots very nicely. So that square root of 100 is a 10, and then that 10 is going to get raised to the third power. We actually can do the same thing on this next problem. 16 needs to be fourth rooted. Well, the fourth root of 16 actually comes out nice. It's a 2, and then that 2 is going to be raised to the negative third power. All right, so then I have a 10 to the third is 10,000 times 2 to the third. Well, 2 to the third is 8, but the negative bumps it to the denominator. And that actually comes out nice, I believe. Let me grab a calculator real quick. So if I take my 10,000 and I divide it by that 8, it's 1250. So 1,250. All right, last one. Again, no variables, it's all numbers, but they all have the same base. So I could do the rule with the exponents because the bases are the same. I could do what I just got done doing, except that 18 does not square root nicely. So that's not going to come out quite as pretty as I would like. So I'm going to do instead the thing where I add exponents since I'm multiplying. Because when you take a 1/2 plus a 7/2, that just gets you 8/2. And 8/2 is really just a 4. In the denominator, we have 18 to the third. So now I'm going to use my exponent rules. If you can imagine this 18 to the fourth, you just write 18 4 times across the top. You're going to write 18 3 times across the bottom and slash, slash, slash. You end up with an extra 18 on the top. I kind of feel like maybe I should have done this slide earlier, but just to kind of recap so that you have a full understanding of the switching between a radical and an exponent and what those mean. We actually will spend some time later on doing radicals, so it's probably worth noting and making sure that you understand if I'm going to cube root an 8, that's really just taking an 8 to the 1/3 power. That denominator is the same as the root. This next one is actually a square root, so that would be an x to the, well, not only am I square rooting it, I'm also taking it to the 7th power. So as an exponential, it would look like that. And just practice going the other way. Here I have a 4. It's being square rooted, but it's also being cubed. So the square root of a 4 cubed. Now, I'm not trying to simplify. That actually would simplify. I'm just trying to write that form and how those connect, making sure that makes sense as we move forward soon doing radical work. All right. Hope you hung with me that whole time. Hope you're feeling pretty good about this. Good luck.